I'm going to cover advanced number theory. Okay, just give me
Okay,
a
sir.
second. Just give me a second. So, what is your combination in college?
Sir, maths honors and physics and chemistry.
Okay, and you are in the final year, right?
No, I'm in third sem right now.
Oh,
Our internal exam is going, so
you're in third
I
sem.
just came back from the college. And
I see. Okay, fine. Okay, so okay, so let's start with advanced number theory. Okay, so let's start with a simple one, and then we'll go into some advanced ones. Okay. What is the last digit in 2004 to the power 32? What is the last digit in 2004 to the power 32? So, do you know the cyclicity of powers?
no, sir.
Okay. So, we have numbers from 1 to 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, when I raise to the power 1, the same numbers will appear, right? 3, 4, 5, 6, 7, 8, 9. Power 2, that means if I square them, right, it will be 1, 4, 9. Then 4 square will be 16, so the last digit will be 6. 5 square will be 25, so the last digit will be 5. 6 square will be 36, last digit will be 6. 7 square will be 49.
Sorry, cyclicity, you mean that it will repeat after a certain number of time
Correct,
that was
correct,
okay, okay,
right?
okay.
So 7,
Um,
7 square is 49, last digit is 9, 8 square is 64, so this is 4, 9 square is 81, right? So you notice a pattern here, 1496, 1496, okay? And the numbers which are missing here are 2378. So no perfect square can end in these four numbers 2, 3, 7, and 8. Okay.
okay, sir. Yeah.
Now you go to power 3. So 1, then 4, 2, 8, 9, 3, 7, 6, 4, 24. This remains 5, 6, 9, 7, 63, 4, 8, 32, 1, 9, 1. So now here the numbers 1 to 9 have all come back, but they are not the same, right? Not in the same order, right?
Yes, yes, sir.
Now power 4 will give you 1, 6, 7, 3, 1, 4, 4, 6, 5, 5, 6, 6, 6, 3, 7, 1, 2, 8, 6, 9, 1, 9. So in power 4 you notice that you have 1, 6, 1, 6, uh, 1, 6, 1, 6, and you have, oh sorry, this is 6161 9981. Okay, so 1616 and here also 1616. Now if you notice the individual powers, 1 always remains 1, 5 remains 5, 6 remains 6. 2 will will have a pattern like this, 2486. 3 will have a pattern of 3971. 4 will have a pattern of 46, and then 7 will have a pattern of 7931. 8 has a pattern of 8426, and 9 has a pattern of 9 and 1. Right?
Yes.
This is called the cyclicity of power. Now if you go to power 5, then again you will get back 1 2 3 4 5 6 7 8 9. So that means 2 repeats in a cycle of 4, 3 repeats in a cycle of 4, 7 and 8 also repeats in a cycle of 4, and 4 and 9 repeats in a cycle of 2. Right? So so here, when we are talking about the last digit of a number raised to a power, we will look only at the last digit of the number and the power. Right? So 4 raised to any odd power will always be 4. 4 raised to any even power will always be 6. So this is an even power.
Okay.
So the last digit will be
6.
Clear?
Yes, sir.
Okay. Now suppose the number is 307 to the power 307. Now what would be the last digit here? Now look at the cyclicity of 7. 7931. This is how it will repeat. Right? So that means,
yes,
that means I have to divide this number that is in the power by 4 and take the remainder. So remainder of 307 by 4 will be how much?
Sir, I'm doing.
Remainder of 307 by 4 is 3.
3, sir.
Right? So this will be 7 to the power 3. The last digit raised to the remainder of the power, which will be 7 to the power 3, means it will end in a 3.
Yes, sir. 363.
Clear? So this is how you calculate the last digit of a power of a number.
Okay, sir.
Okay. Now we go to another interesting question. Find the last digit of 1 factorial plus 2 factorial plus 3 factorial up to 99 factorial. You know what a factorial is?
Yes, sir. Yes.
So what would be the last digit of all these factorials? Sum of all these factorials.
So just give me a second. So 9. Sir, it will be 9.
No. 1 factorial is 1. 2 factorial is 2. 3 factorial is 6.
Oh, sir, it will be 3. It will be 3.
Yes. 4 factorial is 24. Now after 4 factorial, all factorial will end in a 0.
0.
Right? So that means the last digit will be the sum of these 4 digits.
1 plus 2 plus 6 plus 20.
Which is 3. Okay. So
Yes, sir.
So this problem has occurred in ISI exam in previous years.
Yes.
Okay. Number 3. P and Q are 2 prime numbers. Right? You know what is a prime number?
Yes, sir.
And A and B are two integers. Okay. The remainder of PA divided by Q is 1, and the remainder of QB divided by P is 1. Okay. What will be the remainder when PA plus QB is divided by PQ?
So the remainder will just simply get added.
No.
Like,
No. See, you have to understand how to attack these kind of problems. Okay. This is a problem which is based on the basic remainder theorem, right? Now, when I say the remainder of PA divided by Q is 1, what does it mean? It means PA is equal to Q into K1 plus 1, where K1 is the
any
quotient.
factor. Oh, yeah.
It is a quotient, right? Similarly, QB is P into K2 plus 1. Correct?
Yes, sir.
Now I have two equations, 1 and 2. Right? So what I'm going to do is I'm going to add QB to the first equation on both sides. So that means PA plus QB, from this one I can write PA plus QB equals Q into K1 plus 1 plus QB. Can I write this?
Yes, sir. Obviously.
So this is equal to Q into K1 plus B plus 1.
Yes.
Right?
Yes, sir.
So that means this is an integer because A and B are given to be integers.
Yes. Yes.
So this means that PA plus QB is divisible by Q. PA plus QB when divided by Q gives a remainder of 1.
Yes. Oh, okay.
Right?
Yeah.
So then I can write PA plus QB minus 1 is Q into K1 plus B, which means that this number is divisible by
Q.
Q. Right?
Yes.
Similarly, for the second one, I can add PA to both sides and I can write PA plus QB from this one equals PA plus P into K2 plus 1. No problems?
Yes. No, sir.
Exactly the same way that I did the first one. So this is P into A plus K2 plus 1. So which means this is also an integer because A is an integer. So therefore,
So yeah, K1 and K2 are also integers, right?
yes, because that is the meaning of the when I say that when PA is divided by Q, the remainder is 1. So basic remainder theorem says any number is divisor into quotient plus remainder. This is what I did.
Okay.
Right? Where Q is my divisor, K1 is my quotient, 1 is my remainder. So obviously the quotient means it's a integer. Quotient is always an integer, correct? Clear?
Yes, sir.
So then I can write PA plus QB minus 1 is equal to P into A plus K2. Now this means that this number is also divisible by P, right?
Yes. Yeah.
So if a number is divisible by two different integers, then it should be divisible by the LCM of the two integers, right?
So
Suppose
how, sir?
suppose you take any number 60,
Okay.
okay?
Yes.
60
Okay.
is divisible by 4,
Yes.
and
Four. Yes. Yes. Four.
it is also
And
divisible
15.
by
15.
15. Okay, let's say it is also divisible by 6,
Yes. 6.
right? So according to what I said, if a number is divisible by two different numbers, then this should be divisible by the LCM of 4 and 6, right?
Okay. Right. Right. Factors coming.
LCM of 4 and 6 is 12, so
Yes.
60 is divisible by 12. You can try it with any numbers. When the
Yes.
proof
Yes.
is very simple, right?
Yes.
So that means if any number is divisible by two different numbers, then it would be divisible by the LCM
LCM
of
of that.
both the numbers. Now here we are given that P and Q are two prime numbers. So the LCM of two prime numbers will be the product of these two numbers.
Yes.
Correct?
Oh, so therefore there is a remainder is 0.
So from these two I can say PA plus QB minus 1 is divisible by PQ, since P and Q are prime numbers.
Yes.
So that means the remainder when so that means I can write this as PA plus QB minus 1 is some lambda into PQ, where PQ is the divisor, right?
Yes. Yes.
And lambda is a quotient.
Yes.
So that
Any
means
numbers.
PA plus QB will be lambda into PQ plus 1. So that means when PA plus QB is divided by PQ, the remainder is 1.
Okay.
Clear?
Okay, sir.
So your remainder is of PA plus QB by PQ will be 1. Is it clear?
Yes, sir. Yeah.
Now this is a very, very important concept. I just touched upon the concept that when a number is divisible by two different numbers, it will be divisible by the LCM of the numbers. Remember this. Okay. Next one. Okay, this is a very common question which has appeared in multiple exams, including ISI, in the past. What is the largest value of n such that n to the power 5 plus 5 is divisible by n plus 5? Now this is what I call a classic question for an exam like ISI or KVPY. Okay.
Okay.
Now how will you solve this?
So same like just using that element quotient dividend equal to quotient into divisor.
No. Here you can't do that. Here you can't do that because you are asking for the largest value of n. So if you do that, what will you write is n to the power 5 plus 5 is n plus 5 into some quotient, no remainder, it's divisible by this, into some quotient. Right? But how will you find the value of n from here? Right? You can't.
You mean can't.
So what you have to understand is this: n to the power 5. Now what does this tell me? This tells me that a to the power n plus b to the power n is divisible by, now I have n plus 5, right, by
Yes.
a plus b if n is dash. What? Fill in the blanks.
N is integer.
No. A square plus b square. Is it divisible by a plus b?
No, sir.
No. But a cube plus b cube is divisible by a plus b. Similarly, a5 plus b5 is divisible by a plus b.
Oh, so it must be odd.
N has to be odd. Very, very important. Basic concept of divisibility. Okay. So which means that I can see that my power is odd here. The power of n is odd, which is 5. Right?
Yes.
So I will use this concept. So I can write n to the power 5 plus 5 to the power 5 minus 5 to the power 5 plus 5. Right?
Yes. Okay, sir. Yes, sir.
Now if I divide this by n plus 5, what will I get? N to the power 5 plus 5 to the power 5 by n plus 5 minus 5 to the power 5 minus 5 by n plus 5.
Yes.
Right?
Right, sir.
Now this one is of this form where n is odd. So that means n to the power 5 plus 5 to the power 5 will be divisible by n plus 5. So this will give me an integer. Right?
Right, sir.
Now I go to the second part. Now this has to be an integer. Correct?
Why, sir?
Because
So it,
see what I'm trying to do, n to the power 5 plus 5 by n plus 5. This is what I'm trying to do. And if it is divisible by n plus 5, this has to be an integer.
yeah, the altogether must be integer.
Right? So that means the second part has to be an integer.
Yes, sir.
Now what is the value of 5 to the power 5?
25, 25. So 3125.
3125 minus 5, which is 3120 by n plus 5. Right? So this means that n plus 5 has to be a factor of 3120. Then only this will be an integer.
Yes.
Right? correct?
Yes.
So that means n plus 5, for example, if n is 5, then the denominator becomes 10. So that is a factor,
Yeah.
right?
Yeah.
Similarly, if n is 15, denominator becomes 20, that is a factor of this,
Yeah.
right? Now the question is, what should be the largest value of n? Now the largest factor of 3, that means I have to find the largest factor of 3120. And the largest factor of any number is the number itself. Correct?
Oh, yeah. Okay.
So that means the largest value of n plus 5 will be equal to 3120. So the largest, this largest, so n largest will be 3120 minus 5, which is 3115.
311. Oh, 511.
Clear?
Yes, sir. Got it.
Oops. So these are very important concepts. I'm just touching upon the concepts because today is the first day. So I'm just touching upon the important concepts that you should be aware of. Okay? And the more important thing is how to approach a problem. Okay? By looking at a problem, you should understand how should I approach this problem. Okay. Let's go to the next one. Okay. A greater than B greater than equal to C greater than equal to 0, where A, B, C are all integers. Okay, and 2 to the power A plus 2 to the power B minus 2 to the power C equals 144. What is the value of A plus B minus C? Now tell me how you are going to approach this problem. See, in all these problems that I am showing, you should understand that what they test you is on your absolute basics, absolute basic concepts. Okay, but yes, definitely the questions will be such that as I'm showing in the examples, the questions will be such that you have to really understand the concept in depth. Now, if I tell you the answer to this, the answer is very simple. Okay, but
So
first,
can we apply AMGM concept here?
how?
We can take ABC here, all are
Wait,
positive.
wait, wait.
So
Since you mentioned AMGM, AM greater than equal to GM. Now, what is the condition here?
all the numbers have to be positive.
All the numbers have to be positive and it should be a sum. Here you have 2a plus 2 to the power a plus 2 to the power b minus 2 to the power c. So it is not a sum,
Okay.
right? You have to be careful in what you are applying. Correct?
Correct.
Right? Moreover, by looking at the problem, you should understand that in order to find a plus b minus c, you have to individually find the values of a, b and c. Correct?
Correct.
Okay. Now, you have to look at two sides of the equation.
So can
Okay? You have to
okay.
look at two sides of the equation. Now since I can see powers of 2 on my left hand side, okay, obviously this has to be linked to powers of 2 on the right hand side. That's the first thing that should come to my mind.
Yes.
Right? Now,
Right.
what would be the prime factors of 144? How do you express 144 in terms of the prime, in terms of its
The
prime?
12 square is 144, then 3 and 4
Prime,
is
prime numbers.
prime number.
Prime factors are 2 and 3. What are the
2 and 3,
powers?
yes. Uh,
What are the powers of 2 and 3 in 144?
so, so 2 to the power 4 into 3 square.
Correct. 2 to the power 4 into 3 square. Right? So this is my right hand side. So that means I have to somehow equate my left hand side in terms of these two numbers or these two factors, right? So now let us look at the left hand side. So what is so here the condition given is a greater than equal to b greater than equal to c greater than equal to 0, right? So c is my
Yes.
smallest number and all are integers.
Yeah.
C is my smallest number. So let me take 2 to the power c common, and I can write 2 to the power a minus c plus 2 to the power b minus c minus 1 equals 2 to the power 4 into 3 to the power 2. Can I write this?
Yes.
Now, this is an even number, this is an odd number. So the left hand side also need to have a product of an even and odd.
So if we take a to a minus c and b minus c 1, then it can
No, try to understand the logic.
okay.
So your right hand side is even into odd. So naturally your
Yes.
left hand side also has to have the same factors.
Yes.
Now 2 to the power c will be always even for all values of c.
Yes.
2 to the power a minus c will be even. This will be even, right?
Yes.
And
Right, sir.
this is odd. So even plus even minus odd would be odd.
Yeah.
So this would be even into odd. That means
Yes.
2 to the power c has to be equal to 2 to the power 4, or c is 4.
Okay, sir.
Now then what do I get? I get 2 to the power a minus 4 plus 2 to the power b minus 4 minus 1 equals 9.
Yes, sir.
So 2 to the power a minus 4 plus 2 to the power b minus 4 is 10. Correct?
Correct, sir.
So there are two powers of 2 which adds up to 10. And you can see that both a and b are positive integers. Obviously they are greater than c. C is already 4. So both a and b has to be greater than 4.
Yes, sir.
Understandable,
Yes, yes.
right? So now can you tell me what would be the values of a and b from here? There is one last step. So this is of the form 2 to the power x plus 2 to the power y is 10. What could be the values of x and y? And obviously since a is greater than equal to b, x is greater than equal to y. So what would be the values of a and x and y? So what are the powers of 2? 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, and so on. So obviously two positive numbers adding up to 10, both being powers of 2, what would be the numbers? It could be only one combination from here, which is 8 plus
8
2.
and 2, 8 and 2.
This is the only way in which 2 to the power x plus 2 to the power y is equal to 10, where x and y are both positive integers. Correct?
Correct, sir.
So x is greater than y, that means x will be the larger one. So x has to be 3, y has to be 1. So that means here a minus 4 is larger, so a minus 4 is 3 and b minus 4 is 1. So that means a is 7, b is 4, b is 5 and c is 4. So a plus b minus c will be 7 plus 5 minus 4, which is 8. Clear?
Clear, sir.
Now this is the beauty of this. The beauty of this problem is that what you have to do is you have to analyze the left hand side and the right hand side separately and logically relate them in terms of the factors. That's all you have to do.
Yes.
You
Yes.
cannot solve this problem using any other method. Clear?
Clear, sir.
Okay. Okay, next one. Let d1, d2, d3, etc. up to dk be the factors of a positive integer n, okay,
Okay, sir.
including 1 and n. Now you know that for any number the factors will also include 1 and the number itself, right?
Yes.
If d1 plus d2 plus d3 up to dk is 72, find 1 by d1 plus 1 by d2 plus 1 by d3 up to 1 by dk. Now apparently this problem looks a little difficult, right?
Yes.
So now try to think, how would you add up these numbers? Okay, let's take forget this problem for a second. Let's take a simple example. Okay, then we'll come back to this problem. Same problem. Okay, let me take n equal to 12. Okay. Now, what are the factors of 12?
2 and 3.
No.
2, 3, 6. 6 factors.
1, 2, 3, 4, 6, and 12. There are 6
Yeah,
factors of 12,
Six.
right?
Yes.
There are 6 factors of 12. 1, 2, 3, 4, 6, and 12. Right? Now, suppose it
Yes.
is given that 1 plus 2 plus 3 up to 12 is sum S. You can obviously calculate the sum, right? That's not an issue. Okay? This is given. Now what you are asked to find? You are asked to find what would be 1 by 1 plus 1 by 2 plus 1 by 3 up to 1 by 12. This is what you are asked to find. Right?
Right, sir.
1 by 4, 1 by 6. This is what you are asked to find. Now tell me, how will you find this?
So if we take LCM,
First thing is you have to take the LCM of these numbers. What would be the LCM of these numbers?
so it will be 12.
Right. It would be the number itself. So the LCM will be 12, which means that the LCM of all the factors of a number is equal to the number itself.
Yes.
Very simple concept, right?
Yeah.
Okay. Now you have got the LCM. Now what will happen to the numerators?
Then
1 divided by 12 will be 12. 12 by 2 will be 6. 12 by 3 will be 4,
4,
3,
3,
2,
2,
1.
1.
That means you have got all the factors again in the numerator. Why is it so? Because for each factor there is a corresponding factor which will give you 12. 12 into
Yes,
1 is
that
12, 2 into 6 is 12, 3 into 4 is 12. Simple as that. So if you divide 12 by that number or that factor, you will get the what we call the
Factors.
pair factor. So,
Yeah.
so these are called pair factors: 1, 12, 2, 6 and 3, 4. These are the pairs of factors of 12. Clear?
Yes, sir.
Now let's go back to the problem. Now you have understood, right? So now the LCM of all these numbers will be D1, D2, D3 are all factors. So the LCM will be the number itself, which is
Yeah,
n.
DK. No,
Not
N,
DK.
N, okay. Yes, I understand.
Okay.
DK is a factor of N plus.
Because they have not said whether dk is equal to n, so I can't write dk,
Yeah, okay.
right? It will be the number itself, n, and in the numerator I will have dk plus dk minus 1 all the way up to d2 plus d1, which is the sum, which is 72 by n. Now this problem is a very simple problem if you understand this concept, that LCM of all the factors of a number is the number itself. So just by looking at this, you know that my LCM of the denominators is n. So denominator will be n, and in the numerator I will have the sum of the factors again
Factors.
in the reverse order.
Yes.
So that will be 72. So in fact, this kind of a problem you should be able to solve without even using pen and paper.
Yeah.
This is what I call is a mental maths kind of a problem. But you have to know the concept. Clear?
Yes, sir.
Now let's look at a slightly different problem. Let A, B and C be three real numbers. Okay. A, B and C be three real numbers such that A is equal to A square plus B square plus C square. Okay. Find the smallest possible value of b. Now tell me how you are going to approach this problem. Now this problem can be done in two ways, two methods. Okay?
Yes.
Method 1. How will I approach this? What comes to your mind when you look at this?
So a to the power n plus b to the power n divided by it's the powers are even. No.
No, if you have even powers, you can't do anything. Even powers are not divisible by anything. And moreover, here you are asked to find the value of b. Right? So, by looking at the problem, you can see that there are three squares and an a. Right?
Yes.
So, I can write this in the form of a quadratic. And what is that quadratic? A square minus a plus b square plus c square equal to 0. This is a quadratic in A. Right?
Right.
Now look at what is the condition given. What is the condition given?
3 real numbers. So the discriminant must be greater than 0.
Yes, your discriminant has to be greater than 0. Right? Now what is my
Yes.
discriminant here?
Discriminant a square minus 4b square plus c square.
Not a square. Minus 1 whole square.
Minus,
So,
oh yeah,
1
minus 1 square.
minus
Minus 1 minus
4 b square plus c
4 into
square should be greater than 0. That means b square plus c square should be less than 1 by 4.
yes.
Right?
Yeah.
Actually, it should be greater than equal. It can be same. Right? Right?
Yeah.
The roots can be same also. We just said that it does
Yeah,
three real
yeah.
numbers. So discriminant can be greater than equal to 0. So that means b square plus c square has to be less than equal to 1 by 4. Right? Now
Right.
from here you have to maximize b. Sorry, minimize b, not maximize. You have to minimize from here.
Minimize.
You have to minimize b. So what would be the minimum value of b? So the concept is, if you have to minimize b, you have to maximize b square. Why? Why is it? Once again, look at the condition given. A, B, C are three real numbers. They can be both positive or negative. Right?
Right.
So, if I am trying to minimize b on the negative side, that means b square will be maximum, because b square will be a quadratic like this. The minimum value will be 0. Right?
Yeah.
Correct? Understood?
So no, sir.
So If I draw the graph of b versus b square, what will the graph look like? When b is 0, b square is 0.
Yes.
See, you have to be very, very clear about these concepts. They are very, very important concepts for exams like these. Basic concepts. If I draw the graph of b versus b square, the minimum value of b square is 0,
Yes.
right? And
Yes.
when b is negative, let's say when b is minus 2, b square is 4. Again, when b is 2, b square is 4,
Yes.
right? So you have to keep in mind that b can be negative also, not positive, right? So if I have to minimize b on the negative side, I have to maximize b square within the given constraint. Clear?
Okay. Yes, sir.
So the maximum value of b square will be 1 by 4.
Yes.
If b square has to be maximized, c square has to be minimized. It is a square, so minimum of c square will be 0, so b square will be 1 by 4. So this will be
Yes.
1 by 4. So that means b minimum will be minus 1 by 2. Clear?
Yes, sir.
Okay, so this is one method. What is the second method? Second method is, I can write this as, since I'm thinking about b, so I'll just think about b. So b square is a minus a square minus c square, right? Now
Right.
here you have to keep this in mind. I am trying to minimize b, that means maximize b square.
Okay.
This is the concept that you have to be aware of here. So I'm trying to maximize b square. So to maximize b square, first what I'm going to do is, I'm going to equate c square to 0.
Okay.
To maximize this, I have to minimize the negative part. So c square has to be 0. So that means b square maximum will be a minus a square, which is minus a square plus a, right?
Yeah.
Which is minus a square plus 2 into 1 by 2a minus 1 by 4 plus 1 by 4, which is minus of a minus 1 by 2 whole square plus 1 by 4. Correct?
Yes, sir.
So that means b square will be maximum when this is minimum and the value of any perfect square minimum is 0.
Yes.
So that means b square max will be 1 by 4. So b min will be minus 1 by 2. Clear?
Yes, sir.
Okay. Next concept. Find the number of pairs of x, y satisfying x, y into x plus y plus 1 equal to 5 to the power 2018 plus 1, which means how many x and y are integers. Okay. So find the number of values of x and y that will satisfy this equation. Okay.
Okay, sir.
Now, how am I going to approach this? Remember how we did this problem? Yeah, this one.
Okay, comparing even and odd. Yeah.
You have to analyze the two sides. Okay. Same thing here. Concept is same. I'm going to analyze the two sides. Right. The first thing I need to understand is my right hand side. Now my right hand side is 5 to the power 2018 plus 1. Right. Now 5
Yes.
to the power anything is odd.
Always. Yes, odd.
Is
Always.
odd. So this will be even.
Yes.
Right. Now even numbers can be categorized in two different ways. One categorization is it can be of the form 4k or it can be of the form 4k plus 2. This is one categorization of even numbers. Okay. The other categorization of even numbers, which I won't use in this case, but in other problems we'll need that, is even number can be of the form 2 to the power k or 2 to the power k into p, where p is odd. Okay. Now let's take an example. So if I use this categorization, so 4, 8, 12, etc. will fall into this category, and 2, 6, 10, etc. will fall into this category. Correct?
Yes.
Okay. Now 5 divided by 4, the remainder of 5 divided by 4 is 1.
Yes.
So the remainder of 5 to the power 2018 by 4 will be 1 to the power 2018,
Yes. Yes.
which is 1. Right?
Right.
So that means 5 to the power 2018 is of the form 4p plus 1.
Yes.
Remainder is 1 if I divide by 4. So that means 5 to the power 2018 plus 1 is 4p plus 1 plus 1, which is 4p plus 2. So that means this is of this this category, right hand side.
Yes.
Okay. Now I go to my left hand side. Now my left hand side is xy xy into x plus y plus 1. This is my left hand side. Now obviously this has to be of this form because my right hand side is of this form. Now what can be the possibilities? X, y are both even. Now if that happens, then x into y will be
Even.
divisible by 4.
Yes.
Right?
Right.
So that means that will go into this category, 4k. My left hand side will become 4k. So this is not possible. Right?
Yes.
Now next is xy, both odd. Now if both are odd, this would be odd and this would be odd plus odd plus odd. That is odd. So my left hand side becomes odd, not possible. Now the third option is 1 of x and... Just give me 1 second. So my third option is x is odd, y is even, or the other way around, doesn't matter, right?
Yeah.
So in that case xy will be even,
Yes.
and this would be even plus odd, that will be even. So even into
Yes.
even will become 4k.
Yes.
So this is also not possible. So there is no value of x and y that will satisfy this equation.
Okay, sir.
Clear?
Clear, sir.
So I hope whatever I covered today gave you a good glimpse of what level you need to get into. Okay?
Yes, sir.
Concepts are very
Definitely.
simple, but yes, you have to really go deep into the concepts. Okay? So we'll continue this in the next class. Okay?
So next class also number theory.
Yeah, I mean, I'll continue with one more class on, or maybe two more class on number theory, and then go into other topics. Okay.
Okay, sir. Okay.
Okay, so that's all for today. Take care. Bye.
Okay, sir.